Recording. Yeah. So the next presentation is by Philip Rudiger, and he is going to speak about build polished data-driven application directly from your Pandas or XArray pipelines. And if I'm not right, Philip, you're associated with Anaconda, right?
That's right. Yeah.
Yeah. All right.
Hopefully everyone can see my screen.
Yeah, I can. And if you could just start with a short bio of yourself, that would be wonderful.
Okay, yeah, perfect. So yeah, my name is Philip Rudiger. I'm based in Berlin, Germany. I work for Anaconda here, and I'm a senior software engineer, primarily working on kind of open source software or develop various open source tools, which you'll see in the course of this presentation. And yeah, I'm very excited to share this talk with you. All right, so I'll just jump straight in. I'll be talking to you today about building polished data-driven applications directly from your Pandas or XArray pipelines. So to start off with, what do I mean by a pipeline? So let's take a very simple sentence as an example. A person drives to the store to buy food, then he drives home, prepares, cooks, serves, and eats the food before cleaning the dishes. And so in Python, you might want to write this as a series of methods operating on some object. So you might have a person that kind of performs various actions, such as driving to the store, buying food, driving home, preparing food, cooking food, serving food, eating food, and then cleaning the dishes, right? And so in Python, we call this method chaining, and that's really what I mean by building pipelines in Python. So let's jump straight in and look at a particular data pipeline, so actually operating on some data set, right? So here we're looking at the Seattle bike data set, which is here loaded as a data frame. I've skipped the loading step. And so we now might want to perform a range of operations, right? So this is actually a pretty large data set. If we look at the length of this data set, this is actually pretty long. And so we might want to resample it on a daily basis. So we're resampling it, take the sum, and then we want to smooth it a little bit because it's quite noisy data and it might jump around. So we provide a rolling window, right? Perform the sum on that, and then we might want to plot it. And so here we're using hvPlot to plot it, which gives us this nice interactive plot. We'll talk about that in a little bit. But really what we're focusing on here is this pipeline of operations. And so both Pandas and XArray, as we'll see later, provide this ability to chain various operations in a row to apply some pipeline. But at the same time, we've picked relatively arbitrary decisions here, right? So daily resampling, we actually have this data on a kind of a minute basis or even at a final resolution. So daily is kind of an arbitrary decision. This particular value for the rolling mean or rolling sum is a very arbitrary value, more smoothing, maybe we want less smoothing and so on. And so every time we want to change any of these things, we have to go back in, edit that, and kind of find the actual the particular values that we want or that's appropriate for the effects that we're trying to find, the kind of particular transformations we want to perform on our data, and that process can take a while, right? It's kind of going back and forth. And so that's what I'm talking about when I talk about exploratory workflows. And if data is messy, you have to iterate on it. You have to really, to make discoveries in your data, you have to be able to iterate on it fast. And so fast iteration cycles are what makes discovery possible and what has made particularly notebooks so very popular, right? They let you kind of do this kind of process of going back and forth between editing the code, viewing the output. And so that's why notebooks are powerful. But even a small amount of coding, the bit I was just talking about, kind of editing these particular variables here, even that kind of interrupts this fast iteration cycle, right? So if we're trying to find the particular rolling window that's most accurate, kind of going back and forth and incrementing the value or decrementing the value, it takes some time, and it's kind of interrupting, and it's not really what we want. And so that's why are we introducing this new concept of int.interactive, which I'll kind of explain in a bit more detail in a minute. The original inspiration for it came from Tom Nicholas in this issue on XArray. And so we won't to dive into the issue, but if you want to kind of dig into that and see the discussion there, it's quite interesting. But I'll just read the kind of description of the problem out that Tom Nicholas provided there. So for most users who are exploring their data, it'll be common to find themselves rerunning the same cells repeatedly, but with slightly different values. So why not allow them to add widgets directly to their pipelines? But importantly, we also need to make sure that We don't require users to kind of learn new APIs. They should just be able to use their existing knowledge of kind of the Pandas API, the XArray API, to just drop in widgets and get an interactive version of their existing data pipeline, right? And so what is .interactive? Well, right now it's a monkey patch accessor which supports the common data APIs, whether that's Pandas data frames, Dask data frames, Rapid's cuDF data frames, or XArray objects. It is shipped with the hvPlot library. So we'll dig, as I promised, we'll dig into what the hvPlot library is in a minute. But .interactive allows us to chain these interactive pipeline methods and replays when any of the inputs, i.e. any of the widgets that we feed into this pipeline, change. It also supports dunder methods, which allows us to do mathematical operations. So if you're not familiar with dunder methods, it's basically the things that allow objects to implement things like mathematical operations, plus, minus, multiplication, and a bunch of other stuff, right? And then it also mirrors the API of the wrapped objects. And so let's take an example here. So let's actually get it started with an example. So the way we install the .interactive API on our Pandas objects is by importing hvplot.pandas. There's also a method you can import or a function you can import to enable this explicitly. But this import is the simplest way to get started. And once we do that, we have this interactive accessor on our object, which turns our regular data frame into an interactive object. And so here we now have a handle on this interactive object. We can now perform all the regular operations that you might want to perform on a Pandas data frame, except it now supports widgets. And so if I, for example, create a panel widget, a date range slider widget, I can now kind of filter the index by the start value of this date range, the end value of this date range, and then basically show us the first 3 rows. And so now when I drag this slider here, we can see the output below update in response to the dragging of the widget. So in this way, we kind of built a very, very simple interactive pipeline, right? It's basically just 2 steps, filter, and then call .head. So we can see the first 3 rows. Very simple, but it kind of gets the point across, right? So how does that work? And so if you don't care, tune out for just a second. I'll just briefly talk about how this actually works, right? So when .interactive is instantiated, it wraps the starting object. So here in this particular case, right, when we call this, we're wrapping this Seattle bikes data frame. It queries that for its methods and dynamically mirrors its APIs. So internally, that's just calling getAttr, setAttr, and those are mirrored. Those are basically intercepted. And so whenever you call any method, it kind of checks, does that method actually exist on the underlying object, and then intercepts that. It also, when you make any method call or kind of do the slicing semantics, it intercepts any widgets or parameter objects you're passing in and wraps those to ensure that those are interactive inputs to our pipeline. It also implements various dunder methods, so we can do the mathematical operations. And then when we access any method, it temporarily stores that method accessor so that we can resolve it when it's called. And finally, when the output is displayed, it's rendered using the panel library or HoloViews potentially. And whenever any of the widgets or inputs change, the output is updated. So that's helpful. So before we dive any deeper into how this works and what you can do with it, let's just briefly discuss what is hvPlot, what is panel, right? Not everyone's familiar with those. So hvPlot is a library I originally wrote to kind of mirror the .plot API, which is present on Pandas objects, on XArray objects, which provides you kind of static Matplotlib output, but provides a really, really convenient entry point to kind of do exploratory visualization of your data. So it also supports GeoPandas, Dask data frames, Rapid's data frames, and a few other libraries. It then renders the outputs to HoloViews objects, which in turn give you an interactive bokeh plot that you can kind of zoom in on, explore, which is different from the regular Matplotlib output you're used to from Pandas. And so this new .interactive API, which also lives in hvPlot, now extends these interactive processes that we've kind of added for visualization to data exploration, data manipulation, and makes those interactive for you too. So all of that is also built on top of Panel. If you're not familiar with Panel, it's basically a dashboarding library, kind of a very high-level dashboarding library, which lets you build applications either in Jupyter, and kind of prototype them in Jupyter, and then lets you deploy them on a Bokeh server. So it supports rendering a wide range of widgets, all different plotting libraries that you might think of in the PyData ecosystem are supported. And this way we can kind of take the output and update it whenever anything changes. So that's very helpful. So that's the two libraries this is built on. Now let's actually look at a data pipeline where we're applying some of these concepts that we've talked about, right? So previously we kind of talked about, we have this Seattle bike data set, we've made it interactive, and now we can call various methods on it to build this interactive pipeline. So instead of kind of providing just the daily resampling, we now provide a widget which allows us to switch between daily, weekly, and monthly resampling. Instead of providing a fixed rolling window, we provide a widget that allows us to kind of have a slider to change those values, right? And so now, just by kind of replacing this original data frame and replacing the fixed arguments with widgets, we've now built this interactive little app that lets us switch between daily, weekly, and monthly resampling, allows us to adjust the rolling window. And so here we can kind of smooth it until we have the particular plot that we want or gain the insight that we want, right? So we can see it's kind of, we've got in winter, bike trips kind of drop, and summer they pick up. And so this is something, well, we can also see in the daily version, but in the monthly version, we might not see it. And so here we can gain the insights that we want just by kind of fiddling with widgets instead of kind of manually editing the values in here. So I also promised you this would also support mathematical expressions. So again, we've kind of resampled our data. This time we just fixed the daily resampling. But then we provide the window as an interactive input. We've assigned that to a variable, which then allows us to kind of take the resampled version, the interactive resampled version, and subtract the mean of that from itself, which basically gives us the difference from the mean. So we can see here how things drop below the average, kind of the number of bike trips drops below the average in, I assume this is winter, and then pick up again. So here, in this way, we can perform any operations that we want. You'll also notice here that we've used hvPlot again to plot it, which means we can get hover information, we can zoom and pan around, right? We've also provided rasterization here, which means that if we were to do this on a, I always forget what the, this is monthly, I think. If we did this on a, if anyone can remind me what if we had a second resampling, this might take a little minute actually. So that was probably not the best idea. But using this rasterize, we can even get visualized data sets this large. But that was a particularly terrible idea of mine. So for now, I'm going to have to stop the kernel there and then restart the presentation. So sorry about that. Don't resample such a large data set on a secondly basis. Is the basic is the idea there. Okay, so we've seen that we can perform kind of method chaining, we can perform mathematical operations, but we can also kind of provide our own methods in this data processing pipeline such that we can pipe things into other functions, other objects. And so here we've built this little interactive applet where we now take a different data set, the penguins data set. If you're not familiar, it's just a collection of penguins in the Antarctic, with various measurements about them. And so again, we're kind of declaring two widgets, A, to filter by the species, secondly, to filter by the sex. And then we can again use the regular Pandas semantics to A, do the filtering. And then we can pipe that into any object that we want, any function that we want. So here we're piping it into this tabulator widget. Tabulator is a very powerful kind of table widget that exists in Panel, which has things like pagination, so that if this was 10,000 rows or a million rows, this would still work. It's just fetching particularly the rows that we want. And now if I kind of switch between the different species, you can see that the table below also updates. If I switch species to the sex, you can see the table updates. And you can see here, we can kind of go to the last, flip through the pages. So that's quite powerful. This pipe method, which exists on Pandas data frames, kind of lets you do arbitrary transforms using a function. And in the context of hvPlot.interactive, this is a superpower because it lets us pipe things into any object that we want and render our data in various ways. Okay, so another very important concept are terminating methods. So a pipeline, right, keeps piping data. The more methods you add, it keeps piping the data through. Like every time it returns a new object, you're chaining things. But at some point, you might want to kind of get the actual object that you're rendering back. You might want to terminate this pipeline into an object that you can display or work with in other ways. And so that's what the terminating methods are for. There's 4 of them. One basically is the HoloViews method that just returns a HoloViews object. This only works if the object that we're terminating on is a HoloViews object. And so in the case of using hvPlot, you would get a HoloViews object back, and that's when you'd use this. It's just this kind of does an efficient update of the plots. That panel, kind of your data could return anything. It can be a data frame itself. It could be anything we can pipe into a panel object. Panel will render and update as the widgets change. Then we can also get back the widgets themselves, right? We want to lay out the widgets separately from the actual output, put them in a different place in our little application, and we'll see that in a minute. And so in this way, we can kind of get a layout. We can also get a layout of both the widgets and the panel in one. So it's kind of a helper around getting a column of these 2 objects. Okay, so those are the terminating methods. So far, we've focused entirely on Pandas data frames, but the title here promised that this would also work for XArray datasets. And so here we're going to work with a very simple, this is the, in the XArray docs, you'll find this particular data set quite frequently. It's air temperatures over the US over time. So this is basically, if you're not familiar with XArray, XArray is basically a pandas for n-dimensional data. So here you can think of this as a 3D cube of air temperatures as a grid over the US over time, right? So you've got images which are stacked over time, and so you've got this 3D stack. And so the nice thing here is this also supports interactive. And so we can do basically a integer selection. We have an integer slider starting at 0, ending at 10. And now we can slide over each slice in this object. So we're stepping through time here. Here, this little repr is the representation that XArray provides for this particular output. So as we're going through time here, you can imagine we're kind of crossing through time. But more interestingly, we can kind of actually use the hvPlot API to plot this as well. And so here you see the same data set now, again, explorable through time, except we're now using the cell method, which is basically selection by actual variable value. And so here we're actually getting the output here is no longer the integer, but the particular time that we're slicing on, right? And so interactive is quite smart here. It actually knows what the cell method is. It kind of can infer that if you give it a discrete slider, that it should create an instance of this discrete slider and populate it with all the times so that we can cross through time. We're also, again, making use of the mathematical expression operations so that we subtract the mean air temperature over this entire time period so we can kind of see the divergence from the mean. And then finally, we're also providing another widget to kind of select between different types of plots. So here by default, we're plotting the image, plotting this as an image. We can also switch to plotting it as a contour or a filled contour. And all of this still allows us to switch to kind of drag the slider to go through time. So that's pretty neat. Again, works just in the same way as Pandas. And in fact, one other nice thing is that since we're just mirroring the API, right, all the docstrings still exist. So if you're doing if you're working in IPython or in a notebook, we can still get back the docstring even on this interactive object, right? So that's really nice. The other nice thing is, of course, we've kind of focused on hvPlot output because it's cool and it gives us these interactive plots. But the regular .plot API, both for Pandas and XArray, still work. So here we're again doing this time slider thing, but this time we're just using the regular .plot API to plot this using Matplotlib. So that works too, which is also pretty neat. We're also not stuck with the particular type we started with, right? So we might, there's actually a way to go from an XArray object to a data frame. So we can kind of build a pipeline where we select on the XArray object by latitude, and then we group it over time and plot the mean temperature at that latitude over time, also by method chaining here. So we're chaining, going from an XArray object to a Pandas object, just chaining this operation, and now we can kind of select the latitude we want to look at and see how that changes the air temperature. So really, it's very, very flexible. And we can do almost anything in this way. Another thing that I've kind of focused on is Panel. This is all built on Panel. So Panel is a natural kind of widget library that you can use. But if you want to use an IPyWidget, that works too. You can just drop in any IPyWidgets object in place of the Panel object, and that'll work the same. So here we've got a player widget from IPyWidgets, which we dropped in, and we get our little player. Okay, so I kind of, let me just check the time. Okay, I do want to leave some time for questions. But what I did promise you is that we're not just building pipelines, we can actually build an actual application and a polished application at that from using this, right? And so what we're going to do here is we're again going to start with a different data set. In this particular case, we're going to go through the entire process of building an application here. So I'll just drag this off screen a little bit. So what we're starting with here is this earthquakes data set. This is the earthquakes across the entire globe over, I think, a decade. I'm not quite sure. We again start with this data set, which is again a data frame. We make it interactive. We add some widgets. And then we again use regular Pandas API to do the filtering, kind of to allow us to filter these earthquakes by magnitude. This is the minimum magnitude. We again use a date range slider to filter it by time. And then we look at what that looks like, right? We again have this little interactive thing just to view the table and preview the table. And now we're going to kind of create various filters, various plots of this. So let me just go back so that we can actually see the plot. So there's something odd about this. Let me re-execute. Oh, up a slide. Sorry about this. So we're just going to re-execute this and then go back here. I think I'd re-execute this as well. And now we can actually see all of these earthquakes across the world. If I could actually go back, then yes, we can see them all. Sorry about that. And so now we can zoom in and actually look at, this is, I mean, several thousand earthquakes, right, across the entire globe. And we can see all of them. And using the data shader library, we can visualize and make sure this is still interactive. So we've declared this GeoPlot we're going to add to our little dashboard. We're going to create some other plots we're going to add to the dashboard. Here are some histograms we're going to add. Another thing we might want to add is a little table. Again, this is, sorry about this. Rise is kind of cutting my things off, so I have to go back and forth a little bit. But here, again, we're going to create a table using the tabulator library to kind of view the particular earthquakes that we've subselected, right? So again, this allows it to filter the whole thing. And so we're just creating various components to add to our little dashboard, right? And all of these components are created using the interactive API. We finally lay this whole thing out together. Here, we're going to put the plots in a separate tab from the table. And so this is what Panel will let you do. Kind of, it provides various layouts that lets us lay things out in different ways using either columns or tabs. Again, this is a little bit cut off, but in the final polished dashboard, we'll see that this actually looks pretty nice. And so just to summarize, what we've just done is we've kind of made our earthquake data set interactive. We've filtered it in some ways. We've created various plots from it, such as the geographic plot, histograms. We've created a little table from that. We've put that into a set of tabs. And now we're going to add all of that to our little polished dashboard template. So panel, if you don't know it, provides various templates that you can just drop your components into. And the API for that is very simple. So all we're going to do here is append our widgets to the sidebar, append our tabs to the main area, and then we're going to preview this thing. Just let me sure before we do that, let me just make sure that I re-executed this so that it all just works. And now this show method will let us preview this. If we actually deploy it, we could kind of put this in a script or in a notebook and make that work nicely as well. And so here, just by adding this interactive pipeline that we've built to a dashboard, to this template, we can create this really nice polished dashboard. We can kind of change our filters. We can adjust the filters. The other nice thing we added to this dashboard, and if you watched very closely, I added this thing called linked selections, which I actually talked about at PyData Global last year, which kind of lets us filter by region. So let's take this region here over Japan and filter by that, which allows us kind of see here, all the other plots will update in response to the selection now, because I used linked selections. You may be able to see in the background very faintly the full data set and then the subset of kind of data points that fall into, that correspond to the region I selected. I can further sub-select, right? Just select magnitudes from 5 and higher or 7 and higher, or I could also sub-select the depth. And then even the table will update correspondingly, right? So we primarily have earthquakes in Japan and Russia selected now. So hopefully what you can take away from this is just in a few lines of code or using APIs that you already know, you can build an interactive pipeline and then drop the resulting plots, the resulting analyses into a little panel template and get a really nice and polished application. And I think this is less than 60 lines of code total. I think it's probably more like 40 actually. This also has a nice feature. You can kind of, I don't think it works in this particular case, but you should also be able to toggle between dark and light themes. Okay, so let me just go back to our little presentation here. Hopefully we still have some time for questions. Hopefully I can go to the last slide. All we need, I think I just crashed my browser, so we're going to finish it here. The last slide, just thanks all of you for joining here. Maybe I can restart that. Thanks for joining, everyone. You can find more information about this at holoviz.org. So this has a whole tutorial explaining all of this. If you have any questions, you can visit us at discourse@holoviz.org. And really, yeah, I'm looking forward to your questions at this point. Thanks very much, everyone.
Yeah, thank you, Philip. This was a wonderful presentation, and I really like the demos. So we do have questions for you. The first question is like, what is the software you're using to present? I think this is Rise, right?
This is Rise, that's right, yes.
Yeah,
I've been using it for years. It's, yeah, Damien Avia developed it originally. It's really great. It's really just a wrapper around notebooks. So maybe if I drop back out of here, if you install the extension for a classic notebook, you get a little button here that lets you kind of present, and it also lets you kind of annotate for each cell, whether that should be a slide or a fragment. Okay, hopefully that covers that.
Yeah. So people are really keen on seeing your slides. So would you please share these and share the notebook in the Slack channel?
In the Slack channel, I will have to upload it. I've only just put the final tweaks on it. So if you go to my GitHub, I'm going to create a new repo. I'll call it PyData. Oh, maybe we can just do that together now. I'll create a new repo called PyData Global 2021, and I'll put it in there. Yeah, just check back in an hour or two, or well, probably more like 20 minutes. Thanks.
Awesome. I do have another comment which is this is great. This is great presentation. The total opposite of death by PowerPoint. Yeah.
Appreciate it.
Another question is by Andrea. Does it also work in a Streamlit app?
That's a very good question. I haven't tried. So in theory, at least it'll render. I don't know if the widgets probably won't respond, unfortunately. So you can use panel instead, which kind of competes. We've heard a little bit. I think there was a discussion yesterday, which I unfortunately had to miss, about the drawbacks of panel versus Streamlit. But I'll hopefully start a conversation with the Streamlit devs so we can kind of hopefully make this work somehow.
Okay. The other question is, how is this deployed to users?
Okay, so if you, that's a very good question. So if you go to panel and the user guide, it has a whole section on kind of deployment, deploying and export, particularly server deployments. Really, there is a command line arguments or command line tool where you can just do panel serve and point it to the dashboard, and that'll start a server, which you can deploy on any of your favorite cloud providers, such as AWS, Google Cloud, or wherever you want. So here, the show method really just to preview. If you instead put servable here and save that, I could now run on the command line panel serve PyData 2021 IPyWidgets, and that would start a server, which you can deploy on any of your favorite cloud servers. Right?
Yeah, that seems like an easy way and very accessible. Yeah, so Philip, we are almost at the time. So I would just close this presentation and thank you very much for joining us today and giving this beautiful presentation. And I hope you have joined the Slack. Yeah, I hope you have joined the Slack.
Oh, yes, I should. I haven't.
Oh, yeah, sure. So shortly. Yeah, because I see there are a couple of questions who are coming here and you could ask Philip on the Slack. So Philip, there's a talks Slack channel, sub channel of the whole workspace, talks, where you can post all your slides, notebooks and everything, and people will just start a thread with questions and everything.
Okay. Thanks so very much for moderating. And yeah, I'll post this repo here there once I've uploaded the slides as well.
Sure. Thank you very much.
Great. Thanks, everyone. Bye.
Hello, Alan.
Hello. 1 minute. I can show my video. It says you can start your video because Moses stopped it.
No, I think you would be now. Can you try?
All righty, perfect. Thank you very much.
Awesome.
Good morning or afternoon or evening, wherever everyone is.
Evening. It's evening for me.
Let me share my slides real quick.